So page 66, number 32, 34, and 36. 32 and 34 refer to int x. What is int x? Remember, I mentioned it in a prior video. If you want to know what int x is, always pop back here to page 64. Here's the graph of int x. All right, I went ahead and copied it onto my note sheet here so that we could look at it. And then once you understand the graph, answering these questions is easy and really requires no justification because there's nothing to justify. So, you know, when you're looking at the answers in the book, just make sure you understand why those answers are what they are for number 31, 33, and 35. All right, so on 32, it says the limit as x approaches 0 from the left of int x. This is our function int x over here. I forgot to label it. So if we're approaching 0, the x's are approaching 0, but they're approaching from the left. That means here we are on the graph here. The value that is being approached, the y value is being approached as x approaches 0 from the left, but is not equal to 0. That value, these values are all -1. They're only -1. They only jump to 0 when x equals 0. But remember, x approaching 0 is not the same as x equals 0. In fact, it specifically means x can't be 0. From the left means we're to the left of 0. So where's the graph to the left of 0? It's at -1. That's why the limit as x approaches 0 from the left is -1. All right, x approaches 2 from the left. X approaches 2 from the left. All right, here's 2. We're approaching from the left. The y values you get are all 1. So it equals 1. All right. This one, you can try graphing this on your graphing calculator if you want. Remember, you get the absolute value in your graphing calculator by going math, num, and abs, right? Math, num, abs, that gives you absolute value. However, you can also get this graph just by thinking about it. So if you think about, you know, what's going to happen with x over absolute value of x? Well, if I have a positive number, then this is just x over x, which is 1. So I'm always going to have 1 for any positive number that's not 0, all right? If x is equal to 0, this is undefined. So that means this must be an open circle right here. That's why I hesitated to fill it in. We need to figure out what it is first. Now, if x is a negative number, then you'll have, for example, -3 over 3. It'll be -1. So any negative number is going to give you -1. So any negative values are going to give you -1. So just by thinking about how that function works, you can see what that graph looks like. So what is the limit as x approaches 0 from the left? So if we're to the left of 0 and we're approaching from the left, my values are all -1. So limit as x approaches 0 from the left is equal to -1. So by the way, let me just ask a fun question that's not in the book. Let's call this number 36.5. All right. What is the limit as x approaches 0 of x over absolute value of x? What's the limit as x approaches 0 of x over absolute value of x? It does not exist because the limit from the left is not equal to the limit from the right. Okay, let's see. I guess we've got time to pop into number 38 here. So in 38, you have a bunch of true or false questions. It's all true or false, right? These are, which are true and which are false. Okay, so. You can, some of them you have to just say true or false for, but I want to get a little bit better than that to the extent possible and show some justification. All right, so for example, when I'm looking at number 38A, so one thing to keep in mind is right hand and left hand limits you don't really have a way to justify. Only full limits you have a way to justify. So what I'd like you to do is, where possible, if it's true, justify it. If it's false, give what the correct answer is. So this one says limit as x approaches -1 from the right is 1. So as we approach -1 from the right, do we approach the value of 1? Yes, we do. So part A, yes, it's true, and there's no way I can justify it because it's a one-sided limit, so I'm just going to leave it at that. So part B says, limit as x approaches 2 of f of x does not exist. The limit as x approaches 2 does not exist. No, you know what? The limit as x approaches 2 does exist. So I don't want you to just say false. Yeah, I mean, you can say false, but I want you to say what is true then. Limit as x approaches 2 of f of x does exist, and since it's a full limit, let's justify it, because the limit as x approaches 2 from the left of f of x is equal to the limit as x approaches 2 from the right of f of x. And if I come from the left, I come from the right, I come to the same value, which is 1. Okay, part C. C says the limit as x approaches 2 is 2. Is that true? Is the limit as x approaches 2 equal to 2? No, it's not. The f of 2 is 2, but the limit as x approaches 2 is 1, because in the limit, x is not equal to 2. So we're just looking at the points just outside the hole. So in the points just outside the hole, you have 1, not 2. So part C is false. And let's say what it really is. Limit as x approaches 2 of f of x equals 1, because the limit as x approaches 2 from the left of f of x is 1, and the limit as x approaches 2 from the right of f of x is 1. Right, so give the correct answer and justify it. Let's try to do that for all of these. And maybe I'll do that for the rest of this, and maybe not. We'll see you in the next video.